Hi, welcome to this portion of the Building Bridges Conference hosted by Washington State University. My name is Matt Rayo. I'm the Senior Network Engineer for Edmonds College in Linwood, Washington. We will be covering exploring Layer 2 over IP networks, new SDN concepts. In this executive summary, you are going to learn that Layer 2 SDN can enable state and federal agencies to rapidly build secure cloud structures that rival and beat the big three: AWS, GCP, Azure. Now, I'll just stop right there. That is a huge statement, and it's a statement that I take very seriously. But hopefully, for the rest of this outline, the rest of this discussion, we're going to build upon and back up the reasons why I believe we can do it at this point. But a little bit about me and some of the projects that I've been on. From 2014 to 2016, I was the author of the official Getting Started Guide to GNS3 1.0 for the GNS3 team. From 2016 to 2019, I worked for Charter Communications, where I helped develop and actually design a self-heal system. We'll get into that in the artifact section. And currently I'm at Edmonds College, where I was hired on to at least build the STEM building and then tackle the hybrid cloud solution that I'm favoring over just going all one cloud service provider. So this is really a series of projects that have kind of accumulated over time that have kind of helped me to understand why we're able to do what I think we're able to do, which is build our own cloud infrastructure. And also, I'm a part-time adjunct professor. I teach network essentials and operating systems for City U of Seattle. So I do that part-time. It kind of helps me to basically cement those foundations for myself, much less than as well as teach others. And I think it just, when you look at the entire area of the body of work that I've done, plus what I'm working on with cloud infrastructure and that I teach network essentials, you kind of see where at the end of this lecture, I see that we're able to build our own infrastructure. The last part I put over here is I'm pursuing a master's in information security at Champaign College. The pedagogy is really well written. I feel it's very close to my learning style, and so I've got all kinds of things going on, and I think it just, hopefully by the end of this presentation, it'll just kind of bore out all those components kind of come together for this one moment. But we need to do some acknowledgements first. First and foremost, I want to thank my current employer, Edmonds College, for giving me the wonderful opportunity to help design and build a robust campus network for their new STEM building that's now christened the Hazer Miller Building. The entire IT staff are amazing people, foster great teamwork. They have a willingness to adapt to some of the ideas I brought from Charter Communications, such as spinning up a DevOps team and tackling issues like securing the AWS VPC space. So really, I can't say enough about the team at Edmonds to be able to adapt and change and try DevOps, to try Agile, and then tackle something that we haven't built or tried out yet, which was AWS. I mean, it's a real testament to their willingness to try new things, and and it really speaks upon Edmonds itself, that Edmonds is a place that wants to change and grow with the industry to be able to facilitate real-world, hands-on experience that gets passed on to the students and staff alike. So it's a wonderful opportunity, and I'm very grateful for that. At the same time, the senior leadership fostered my creativity to come up with a solution that fits hybrid cloud. But we got to deal with the most minimal cost, includes the existing staff members, instead of going down the path of getting vendor locked into one of the cloud service providers. And this Layer 2 SDN, I think, is that key. The structure of this lecture consists of the following. Section 1 is a discussion of what SDN is. It's going to have a little bit of my OSI model lecture that I teach at City U. Section 2 is going to be the artifacts that contribute why I think we are ready for a decentralized data center structure on top of the existing ones. And section 3 defines the new terms for these novel concepts. So this is brand new. When we're talking about building bridges, we need to start building these bridges. This is gestating into something that I think is going to be very big. Section 1, we're going to define some terms for those of us who may not be familiar with what SDN is, what OSI model we're talking about. This is what this section is. It should be very brief. So one of the reasons why I love working for the education sector is just with the other areas of my career, it's this ability to be able to teach what you're learning, fundamental concepts over and over again, and it helps me to instruct not just for students but for myself, and it just really brings together the various experiences I've had in the last 24 years, from small to large networks. I've kind of got to see it all. One was at a hospital, one's at a startup, one's at a Fortune 300 company. So I got to see networks, which is great. And then City U of Seattle gave me this part-time position, as I just briefly mentioned, where I can teach on this depreciated OSI model. So just as a little side question, if you're teaching the OSI model and it's depreciated, then why are you teaching it in the first place? Well, the simple reason is that even though the OSI model is depreciated it's not really used as much as some of the other ones, it does cover the 7 layers that would cover, a new student or maybe even a seasoned engineer, how to troubleshoot and triage. What layer would these issues be impacting? It helps the student to think critically of what you're doing, and that's a key component. So the idea was if they pass through and understand the OSI model, they kind of know where they're going to end up after that class. So when we're dealing with the OSI and the SDN and that kind of stuff, let's just take it to basics first. Let's just talk about the OSI. Let's just visually look at it. I love talking about it through graphs. When we're talking about the open system interconnection, you can now visually see that from the physical layer, if you just picture some machine, some server that's in a rack inside of a data center, these are the 7 layers that the OSI model does a really good job covering. Now for my class, we tend to cover around 3 and 4 for about 2 or 3 weeks, which is good because by the time they get out of the class, they're prime candidates for the CCNA, CCNP, CCIE track. Maybe they want to go into development, they want to understand the modules and routines that they're calling. So there's multiple benefits to taking this fundamental class. This just happened to help me because we are talking about Layer 2. And the interesting thing about Layer 2 is it's usually confined to a local area network. So what's the benefit of securing and encapsulating that traffic across the internet? That is the million-dollar question that I hope we answer by the end of this lecture. Now we're going to talk about more acronyms. SDN. What is it? SDN, the acronym is Software Defined Network. But even when you hear it, what about the software that defines the network? So you have to get into a little bit of history here. There was this born need to be able to extract the management plane, that is the iOS and the commands that are typically used to configure a machine, from the forwarding and data plane, which is the actual hardware. And why would we do that? And that's simply because when you look at Cisco, for an example, as a de facto standard of networking, they've been that way for many years, they have their iOS and their command structure integrated into the device. So you really had to know what you were doing inside and out of those devices. When you abstract it away, when you pull that command control plane out, well, now you can control multiple devices. It may or may not be the same vendor, and now you can orchestrate the configuration of multiple devices. So we're in a space now where you have routers and switches that are called white boxes. They don't have an iOS on them. You load the iOS on top, or more importantly, you take that control plane and you manage these new boxes. So that's the idea of SDN. But then we're talking about layer 2, which is really bizarre and brand spanking new. Where does that fit in to the software-defined network? So now that you have an idea of the OSI model and the SDN, now we can kind of move on to the next section, right? This whole idea of grabbing layer 2 into the SDN solution, in my mind, is quite fascinating. And like I said, it's very highly experimental. But it doesn't map cleanly across what SDN is to other vendors. So this is brand new. We need to have this discussion. We need to have this lecture now so that we can understand that this SDN is gobbling the layer 2 traffic now, securing it, encapsulating it, sending it out over the internet. The other side's receiving that layer 2 traffic as if it was in the same local area network. So that's huge. And when you really break down all the kind of traffic that happens in a local area network that is confined in the local area network, what does this do to some of these protocols? Well, the timing of this conference is a little bit off because I'm right in the process of testing layer 2. So I haven't been able to check off the list all these protocols, but just imagine what could be possible if we were able to do that for all of them. Maybe some of them, but my goal is to test every single one of these protocols. So now we're going into section 2, the artifacts we have now today. So there are certain pieces to the puzzle. So we're going to kind of be like time travelers, and we're going to look at some of the projects that I've been on that allowed me to readily identify where we are with this technology. And the last one's going to enable us to finish the idea of building new types of data centers across multiple on-prem locations around the world. So the following is a review of these artifacts that make this vision possible. Artifacts that contribute to this new layer 2 SDN. Number 1, GNS3. So little mini history here. Circa 2006 up to when I got involved with it, 2014, it was largely considered a simulator. Something like Cisco has a version of it, Packet Tracer, I think it was. And so it was only relegated to the concept that you're just learning routing for the sake of CCNA certification, which for all intents and purposes, it worked very well and did what it did. But then when I got hired on in 2014, I realized that with a little tweaking of the interfaces, I can actually make this thing emulate real networks. So the concept of being able to emulate a one-to-one network, so we're talking about having a real replica, like almost like a miniature dollhouse model of a real production network all the way up that OSI model. That's amazing. And it actually worked. And I got so excited about it, I rushed over to my former employer and I said to him, look, this GNS3 thing is going to disrupt boot camps. Anyone that wants to work hard and learn how to build networks is going to get that with this device. And sure enough, out of 800 applicants, I got the opportunity to jump onto the GNS3 startup team. And sadly, my time ended when SolarWinds acquired them in 2016 for some undisclosed amount, blah, 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 blah. I can't say anything. There's an NDA tied to it. But the idea was I immensely benefited from being around amazing, unbelievable people, especially people that were on the GNS3 jungle. I think at the time of my exit, there were 450,000 students and engineers that I got to tap into. So we're talking geniuses. And I think they're still part of my LinkedIn network. So hi, everybody. But then with that knowledge, what opportunity, how can I take my skills to the next level? So I shot for a Fortune 300 company like Charter Communications. And then after a couple years working with the automation team, I came up with this self-heal system. Now this is kind of important because it's also a component to, what the 5 artifacts are. With a self-heal system, you have an automation platform. It's a framework. Automations that kick off script after script after script that do a bunch of little jobs for the network, for the company, for the customer. Okay. Also, Charter was in the throes of buying or purchasing Time Warner. So my job was to help facilitate the integration of those databases as well. So aside from the big headache, which is moving people around from both organizations, how are you going to get the data to move around? So it just made sense to use an automation platform. Then came along this issue that I had with the automation platform where we hitched up Splunk to it. And that version or that installation of Splunk is a huge installation. And I was able to leverage the hooks between the two to talk to each other. And the simple scenario was that we had a guy that pretty much routinely on a Saturday at 3 in the morning would have to reboot the services. And I personally got sick and tired of getting up at 3 in the morning. So we basically had this framework talk to the Splunk, and the Splunk would talk back to the framework. And we built this routine where it would automatically remediate and blow away whatever the issue was and sent us a nice little email in the morning kind of showing us where in the code we needed to fix it. So that's the self-heal system concept. It's something that I bring to the education space. It's something that if anybody in education is listening, I would really recommend, trying a self-heal system. But realistically, you're about 3 to 5 years out from actually getting that. Still, it's a great artifact, and it's going to make sense when we start to talk about AI in this SDN network, layer 2 that is. Artifact 3 and 4. We're talking about developing an AWS space. So now this is getting a little more current to what I've been doing. After the STEM building has been established and working great at Edmonds, one of the things that I brought from Charter was the same structure that I helped reinforce in Charter, which is a dev, UAT, and prod. So for those of you who are not familiar with that, these are different spaces of a development cycle. You have the development, you have user acceptance testing, and then you have the production. And there is a specific path. And so one of the cool things that I came up with at Charter was this operational model where it had full-blown escalation paths, development life cycles, and they all go through this reiterative agile kind of sprint thing. And this is where I think Edmonds just was so cool because it's a new way of thinking. It's not monolithic, doesn't do waterfall or cascade. You throw something out there that's functional and you reiteratively work on improving it. So that way you're benefiting, the organization is benefiting immediately from the initial investment. That's kind of the idea of Agile anyways. But in the context of this, Artifact 3, our team didn't have an understanding of AWS or how to secure it. So it just made sense that why don't we take a look at it with a fresh pair of eyes, with a brand new team. So we pulled members from different parts of the IT staff, and we came up with this new DevOps team. And this DevOps team was just going to tackle AWS. Here's what Edmonds came up with, right? This DevOps team. We wanted to secure our traffic, so we had this multi-VPC, virtual private cloud instances, along the lines of dev, UAT, and prod, and they all kind of come into one transit gateway, which secures that traffic. So you're building in another layer of security. You're building in an access control list, routes, all that good stuff. So Edmonds benefits from paying a little bit more money for the transit gateway, just so that we know that that environment is secure, and that transit gateway connects to our firewall ASA, security application. So now you have a secure trunk going through that. and both the on-prem and the AWS cloud has that solid connection. I will say that there is some caveats. Just has to do with the security appliance on both ends, but it's working quite well, and it's got security built into it. Here's the thing about that. The new Layer 2 VPN can bypass all that. It's pretty efficient. But the idea is that, Edmunds is now at the point, and the team was at the point where we have a fully functioning cloud space based on these development life cycles. Artifact number 4, new VMware cloud infrastructure. So while we were working on the AWS and had a DevOps team spun up there, it was better for us to kind of restructure how the organization is administering Windows servers. So what it made sense to do was to basically pull the Windows admins that are supporting physical servers, train them up in VMware to host virtual ones. Just makes sense. And after that restructuring, we have just much better coverage from that Windows domain perspective. And I think the cross-training and also the idea of developing a IT ops team was a huge big win for senior leadership. Because now what it is you're really leveraging the experience and the expertise of your current staff, but you're just uptraining them to handle a virtualized version using VMware, right? VMware actually has a great SDN solution. Does it cover Layer 2? I don't know. Honestly, I don't know. From my understanding, it's Layer 3. But the point is we now have this on-prem cloud instance that can work with the AWS space. So we have an on-prem virtual, now we have the cloud. So artifact number 5, that's kind of the reason why we're talking about this. While I was looking for a solution to minimize costs, leverage our subject matter experts and not be vendor centric, ran across this product that basically doesn't even exist in the US. I'm surprised that we don't even have it, but sure enough, popped up, and it was worth the time to take a look at. What I want to do is during our question and answer session in the next 13 minutes, I'm hoping that, the audience would, ask questions about, where I'm at with testing and see if this is something that you guys would be interested in checking out, right? Because this is highly experimental. But, after years of dreaming about this structure, I finally realized with all the projects that I've been on in the last 6 to 7 years, we now have the components that can form that connection. So now's the time to, really look at this and see if there's an easier, simpler, more secure way to building our own cloud structures. When we're talking about this new Layer 2 SDN, I'm going to have to take some licenses. I'm going to have to talk about choosing words that will help visualize what it is, because we're looking at a two-dimensional model, and now we got to add that layer of network, that third dimension, and it's going to get kind of complicated. So I tried to keep it as simple as possible. I'm sorry for the marketers that are listening, because it might not look good on paper, but it just visually gives you the idea. And the only thing I can kind of associate that was when you're building an environment like GNS3, I call it a sandbox, but to the professional, some people in their professional circles, they don't want to call it a sandbox. They want to call it a proof of concept. It's basically the same thing. But we really need to flesh out, these concepts. So I just had to pick, I had to take some licenses and pick terminology from architecture and that kind of stuff to kind of give the idea of what these new network structures would look like. So that leaves us to the third area. I think I'm doing pretty good on time right now. like I said, we're getting to the vision, to the creativity part of this thing, and now we're going to discuss some terms that I think will fit with this layer 2 SDN solution. The mezzanine. So in architecture, a mezzanine is just this area above the ground that's supported by the construction of the actual thing. It's actually beautiful in opera houses, but I found this picture from Panel Built, which is kind of cool because it looks like they built cubicles on top of cubicles, which leverage a better use of the space. But it kind of underscores where I'm going with this new network. So the idea is we have this decentralized network. It's going to look like a LAN, but it's in different virtual environments across the campuses of Washington. And just it's going to look like there is a logical LAN on top of an existing one. So, I mean, as far as that's concerned, I know that works because I was able to do that with an EC2 instance and then a virtual machine inside of Edmund's VMware virtual environment, and it works. Works great. The question is, can we connect that to other campuses and make sure that it looks like the same local network without impacting that layer, which is your production values or environment? And I can definitely vouch for that it works. We were able to get that one connection going, but this lecture is about sort of like a call to arms, sort of like letting everyone know, all the colleges, everyone that's listening on LinkedIn, everyone that is registered for this thing. This is a viable solution, and I'm soliciting for help, assistance. Maybe we can add some more connections, as it's going to show as we're going to talk a little bit more about this on the next slide. So here's the interesting thing about this slide. Okay, I was making this graph. It's pretty crude, but the idea is that at the time when Washington State University was soliciting for lectures, I just happened to be working on this graph. I got all excited because this is exactly the kind of building bridges that we're talking about. This is new, this is exciting, it's experimental, but the concept is valid in that if you're on the west side of Washington and you have a little space inside of your virtual center, that CPU and memory, and then you've got a university on the east side. They also have space on their virtual environment, and then you got a university in central Washington. We could all get together as architects, develop this local network, right, using the layer 2 SDN, and we could basically build a brand new cloud structure. That's mind-blowing when you think about it. It's very exciting. It's how if this is possible, which I highly feel that it is. I really think that this is a possibility. Think of the possibilities as far as redundancy, co-location, storage, that kind of thing. Now you're leveraging federal and state entities when you think about it. The money, the billions of dollars of U.S. taxpayers has already been invested in these structures. Now we're just going to give off bits and chunks of a virtualized, decentralized data center. Sounds amazing. So that's kind of what this lecture is about. That's what we're talking about here. And then when you think about the CapEx, OpEx side of this, which we need to talk about a little bit, one of the things that I learned from Charter was the difference between CapEx and OpEx. And technical engineers sometimes don't really understand the differences between the two. If you're in IT ops, you kind of understand OpEx. If you're a developer, you kind of understand CapEx. But DevOps understands when your time is building a new structure or when your time is supporting an existing one. In this case, the infrastructure is already built, so there's no startup costs. Now you're just investing in the CapEx, which is just pulling architects together from the different universities to create this, what I call a fraternity. I had to borrow that from college because that kind of makes sense. We're coming together for a purpose, and that purpose is to build this cloud structure. So it's like this fraternity. So here's all the potential benefits that I can enumerate right off the top of my head that I just threw into the slide deck. You're leveraging your existing equipment and data centers. You're leveraging the subject matter experts, the people that have supported you before the cloud and just needs a little up training in the virtualized environment. So you've already got them, and now you're not confined to a particular cloud solution, and which I call vendor lock. And the idea here is that it's sort of the crux of this whole thing. You know, when I'm evaluating our hybrid cloud solution, do I want to put all our traffic and all our data in one cloud service provider? Doesn't make any sense for me to do that. When we're talking about, you know, security issues for some cloud instance like Amazon, you know, we're talking about the SSRF attacks. We're talking about Paige Thompson, who infamously brought awareness of internal AWS employees scanning ports. So it's one of those things where I'm thinking to myself, why aren't we, with the technology we have now, just now, with the Layer 2 SDN, why don't we build our own cloud structure? The architects of this fraternity get together, and we are 100% responsible for everything, soup to nuts, you know, because in cloud, the cloud service provider, you know, they have that limit of responsibilities. They kind of lay that out to you, especially the fact that, you know, they're not responsible in some way, which is just mind-blowing to me, maybe because I've been around too long. But, you know, in this case, you get a fraternity together. They're all vested 100% in this cloud solution. Well, now the responsibility falls within the actual institutions, doesn't it? There isn't another person to pass the buck on. So that's why I like this solution, because it's a lot cleaner and easier to support. And of course, AWS and Azure and Google, they'll come back and say, well, we got security and, well, we got architects and all that stuff. But the criticism I have with that is that you need to learn their system, their architecture, their security. And with a layer 2 like this, you don't need to do any of that. This is just as direct as you can make it. So, you know, how is the big three going to respond to this technology? I don't know, because quite honestly, where this layer 2 SDN solution really hits is at traditional data centers. You know, those nondescript data centers that you never get to see, but they're somewhere in the world, and you have to kind of Google where those guys are. But the huge monolithic data centers kind of, you don't need it. You can send a portion of your data to another virtualized environment in Washington. Let's not even say it's the Building Bridges conference. Let's just say it's not education. Let's just say it's a government agency. It's so easy to set up these small networks and have them interconnect at the layer 2, and then build a very large LAN network that is in disparate locations around the world. I don't even know how you're going to be able to stop that, honestly. Which makes me think, just as I'm doing this lecture, that we're at a precipice. We really are. You could continue supporting some cloud service provider, or you can leverage the technology and build your own cloud environment. That's more direct, right? That's really what this is about. You know, we're talking about building bridges. Are we talking about building bridges under what is popular right now, or are we talking about forging new paths? So I'm all about forging new paths. You know, those are the risks that that's the risk that I take. But it's one of those things where without risk, you can't reward. You can't expect a great reward. And so that's where I think this Layer 2 SDN is a fascinating alternative. So that's all great, but does it actually work? Well, So right now, that's the timing of this lecture. I'm in the process of testing. I think it's very promising. But what I didn't mention was that little, the self-healing system. Well, this layer 2 has an AI component, artificial intelligence component, that is actually securing, encapsulating this layer 2 traffic with very sophisticated encryption algorithm. And the whole point here is the AI is doing basically what a team of network engineers would have had to do. It's just doing it discreetly. It's black boxed into this solution. So there's no human interaction with that. And quite frankly, it makes it very difficult for hackers to be able to, decrypt it. It's just not out in the wild. It's proprietary. So it's one of those moments where, this sounds really great, but does the layer 2 traffic go through? And how good is this AI? So that's where we're at right now. We're right there in that testing. And this is, like I said, a call to arms. I'm reaching out to all the campuses in Washington State. If you're a federal agency, if you're a local state agency, bring it on. Let's try to test this thing and see if we can break it, basically. The assurances I got from the vendor is that you can't, but I've been known to break a lot of stuff. So, all right. So this is really what it's coming out to. We're going back to that OSI model, and this would be a weird session in my class where I would say, okay, layers 2 through 5, blow it away, because basically the software-defined network is going to handle all that. So your application really isn't affected, doesn't really care, just sends it down the OSI model. Your physical layer doesn't care, it's just the channel, just sends it along. But this AI just takes care of all that in the middle. It's pretty clean and simple. And to be quite honest with you, application owners don't really know or see all the little minutia that is going on between TCP and UDP. Because what's the biggest problem with TCP? If you were in my class, you would know high overhead, lots of error checking, very, very CPU intensive. UDP, don't care, right? This AI thing is just going to take care of all that for you. So that's why the solution is so easy to implement. Are we the first to notice this? Nope. During COVID, out of all the terrible, terrible things that have happened in COVID, there's some good things that happen. And there's this anonymous engineer who's in a university on the East Coast. We can't talk about him. We can't talk about his university. There are legal reasons for that. It's not that he doesn't want to talk about it. It's just legalities. So he gave me permission to show this diagram to show that when he set up his servers and he tried his failover, he did see the layer 2 traffic come across. And that server was not on the local campus. That server was somewhere else. And it's almost as if it bypassed the entire thing and it's part of that local network. So it wasn't that I just listened to this vendor and just jumped on. I actually got to listen to this one other individual, and it confirmed what my suspicions are. So now we actually have another person, testimonial, vendor, and then I've actually started testing myself. Now we're just going to pull this all together, all the experiences that I had. We are talking about pulling together and leveraging sort of like a decentralized data center that just completely upends Amazon, GCP, Google's entire business model. Because what is it that I'm pitching to you? It's that we can connect our on-prem cloud to each other, bypass all that, the cloud service providers, and build our own cloud. We could totally do that now. And that's kind of the fun thing. We didn't have this technology before, but now after COVID, we do. Here's the roadmap. Okay? This is just something I threw up. This is what I'm actually doing with admins. You guys are now seeing something that I'm doing with the hybrid. Level 1 was to test the validity of the Layer 2 SDN product between 2 server endpoints, which I've done. 2 is to integrate this connection with another college. So I'm just calling it out to you. Which college is it that wants to connect with this local area network that I have sitting around between our EC2 instance and our on-prem VM? I don't know. I'm just calling it out to you guys. Whoever wants to can. Then we're gonna test that cloud product, right? We're gonna see, does it work with all layer 2? I don't know. We need a period of time to test that out. My goal after this lecture is to get 5 more colleges together and create our first fraternity. I get a little fancy. Fraternita primaria. I might be saying it wrong. I don't care. Some marketer is going to come up with something better. But the idea is that we come up with this fraternity and we build this first global local area network, whatever. Then once it's stabilized, we're going to move some of those services off of AWS, GCP, and Azure, and we're going to put some of those instances in this cloud and kind of see how it interacts with each other's cloud environments. And then we're going to do a little more advanced stuff, routing, switching. What I got to do with that little local area network, that global thing, I'm pretty good with GNS3, so I spun up a router inside my EC2 instance, and I spun up another router inside the on-prem, and they're talking to each other as if they were right next to each other, which is pretty cool. It's almost like it's teleporting traffic. It's really neat. Okay, question and answer session. So at this point of the lecture, I'm going to leave about 9 minutes. So fire away.